Hello, everyone. My name is Marissa Hamilton. I'm here with Tung and Hader. We created the board game Sorry. And a little context onto this game, I created this README file that you guys can now see. This is a text-based board game. As I mentioned, it's Sorry, as in the Sorry game that you played as a child on those rainy days or really snowy days that you were never allowed outside. In this text-based board game, you will play the classic board. All the classic rules we have tried our best to implement. There will be options for up to 4 players in the game and having the option to play against the computer. This will be a chance-based board game on a shuffled deck of cards. So you'll never know what you're going to be able to do until you get your result from the card. So the objective of this game is to be the first player to get all 4 of your pawns from your color start into your home. There will be 41 cards available in the deck and no 6s or 9s. The basic setup for this game is you choose your preferred color once the computer tells you that you drew high on the color, and that the high card will determine who goes first. The gameplay, it's really pretty simple. To start a pawn, you must pull one card. If that card's a 1 or a 2, you get to move your pawn out of the start. If it's a 2, you get the lucky chance of pulling another card out of the deck. There is included the jumping and bumping. If you can jump over your player or another player if it's in your way, and then if you land on an opponent's pawn, you actually kick them right all the way back to the start. There's options to move backwards if you get the 4 and the 10. Now the 4 will move you back the number on the card, 4 spaces, but the 10 will actually give you an option, and I will explain that later on. To note, if your pawn has moved at least 2 spaces behind the start, you may, on your next turn, you could actually get into your safety zone or into your home without having to go around the whole board. To win this game, you need all your pawns home first to win. So that's all 4 in the home space. And then if you want to play again, the winner of the previous game will go first. It's really interesting. So on the board itself, we have a home, a slide, a safety zone entry space, and start, and that's where your pawn starts. So the home is where you are safe. You can't get removed out of there. Once you're home, you do not move that pawn again. So as soon as you get in there, you don't have to worry about that guy. The slide, we have to still implement this, but if you land on the slide position, you will slide that spaces for free. You just have to land on the top of it. So it could be up to 4 spaces or 5 spaces. And anyone in your way, they'll get bumped right back home. The safety zone, you may enter your own safety zone. You can't enter backwards. So if you got a 4 right off the start, after you pulled your pawn out, you can't back 4 spaces up into it. You actually have to pass the start and go back. But the thing about the safety zone is if you don't have enough cards to make it home, you can move backwards on a backwards card. The safety zone entry space, when moving along the track, you may not move your pawn forward beyond your own safety zone. So once you get to that safety zone, you must get a card that allows you to either enter the safety zone or take you all the way home. And the start is where you start the pawn, and you like I said before, you pull a 1 or a 2 and you will land there. Now a little explanation on all the cards that can show up is a 1 or 2. And as mentioned before, those are the cards that get you out of the home. Or if you pull a 1 and you don't have any guys in the home, or you don't really want to take a pawn out of the home, you can move forward 1 space or 2 spaces. Now with the 2 card, you get to draw again and then move whatever that card tells you to move. 3, you just move your pawn forward 3 spaces. 4, as I mentioned, is a backwards one. It moves you 4 spaces backwards. 5 will just move you forwards. 7, it gets a little interesting here. You get to choose between 2 pawns how many spaces you want to apply to both of them. So let's say you want to put 4 on one pawn and 3 on the other. That's perfectly legal in this case. But you can't use a 7 to split a pawn to go home. So if you're only 3 spaces away or something, you can't apply that to that one. You have to choose another pawn that you have out, or just take the full 7 on a separate pawn. 8, basic 1, you just move forward 8 spaces. 10 again is one of the more interesting ones where you get to move forward 10 spaces or backwards 1. Could make a difference somewhere. 11, another very interesting one. You can move 11 spaces forward, or you can switch with another pawn of your opponents. So if they're in a prime location, you could switch with them. Now that's not yet implemented, but it will be for the final iteration. 12, again, just move 12 spaces forward. And sorry, this is a really fun one. Whole game is based off of this one. You get to take one pawn from your start and switch places with your opponent and then bump them all the way back to their start. If there's no pawns in your start or no pawns on any space, your turn is skipped. I am now going to pass it over to Hayder to actually show you how this code is running. Hayder?
Yeah, for sure. I'll just get my screen shared, and here we go. I'm running the main game method, and it's gonna ask me for how many human players I want here. So let's start off with 2. Do I want an AI player? For now, let's say no. As you can see, player 2 drew the card 12, so he gets to choose his color first, and player 2 will be going first. So let's just say 0 for blue, and player 1 will be 1 for yellow. Now you can see the board is printed multiple times, and you can see nobody drew a 1 or a 2. And as well, player 2 went first. Here, we finally have the option to make a choice, since player 2 drew the card 1. And you can see since player 2 is here, he gets to choose either 0, 1, 2, or 3, whichever pawn he wants to move. So let's just move 0 for now. And player 1's turn was skipped, drew 10, and we drew the card 2. So we could actually move 1, 2, or 3. I'm not too sure if that will work since we do have somebody here. So let's move 0 for now. And since we drew the card 2, we get a draw again. And we got a 5, so let's move 0 as well. Now 1 finally drew the card 1. Player 1, sorry, drew the card 1 and gets to move out. So you can see it changes from the options here to the yellow option over here. So let's move 0 out as well. And now we're going to go back and forth between these two until we get an option. So 0, move 8, move 8, and move 3, move 3, 11 once again, move 0. So now we have the 10 card. As you can see, choose a pawn to move 10 steps forward or 1 step backward. Since none of these pawns are available to me, I'll select 0. Now we have the option here, move 10 steps forward or move 1 step back. So I'm going to select option 2. And as you can see, the pawn is moved 1 step backwards. I'll now go over the AI. So I'll just run this again. Let's just play me versus the AI. So here, the AI drew 11 and chose the color 0 for blue. So if I try and choose blue, color has already been chosen. So let's go with yellow. And as you can see, nobody was able to move until the AI drew 2. And the AI decided to move their 1 out. This is a little weird. Let's just skip that for now. Okay, player 1 drew the card 2. And so we get to choose one of these, 0. And the AI, since it was the card 2, I get to go again. And I drew the card 4, so let's move. Yeah, so now the AI is making their own moves, and it's deciding to move this 1 over here. And let's move 3. And let's just show 4 players really quick. So everyone draws a card. Since player 1 and player 3 drew the same card, they're going to draw again. And player 4 has the highest card, so 0. 1, 2, 3. As you see, player 4 went first, and then it will proceed in a clockwise manner. So yellow should be the next to go. As you can see, sorry, since it was 2, he gets to go again. And then as you can see here, yellow's turn, unable to move. Player 1's turn, unable to move. Player 2 turn, red, unable to move. So that's about it for the demonstration, and I'll pass it over to Tong to go over our classes.
Okay. So I'm Tang, and right here I have the class diagram about program. So the first and foremost important class right here is game, where we set up the game and play it. So for the instance variable, we have all players representing the players. The card deck is a card deck that we will draw from to get the card which determine our move. The integer determine like the person or the player to go first. In the game configuration, which store the information about the board. So, and also we have this method right here, including the main method where the game will take place, and setup and place, which are really important method. Setup will get to take the players color and also their orders. And play is where the gameplay take place. Also, we have right here set go first to like set the which color will go first, which is also the player who get the highest card when drawing. Also, so we will go over all the instant variable right here, which are our classes. So we have the card deck where we will generate an array list of integer and randomly draw from it. So here we have get deck size to like read the deck size at the moment, and also renewing the deck, like renewing the array list. And here is drawing randomly from the existing card remaining on the array list or our deck. Next, we will go over the human player and the computer player, which inherit the human player classes. Human player has the card, player name, and color as the instant variable. So this card right here is the card which the player draws from the setup of the game, which determine the order of the game. And also player name and color, which will be used later during the gameplay. So human player has two ways of constructing the object, but we mainly use this one, which has the card that they have drawn at the setup and also their name. But another very important variable is the color, which we will set later with the set color right here. So what is the human player used for? It's mainly used for this method right here, which is the card movement. What this card movement do is get the card drawn during the turn and determine the movement that the human player will make from the choice they input from the console. So it returns a move object. The move object is one of our classes. It is defined right here on our diagram. So the move object include the pawn and the number of steps that the pawn will move, 2 Boolean representing other mode of moving, and also the other pawn in case there is another pawn that needs to be stored in the move. So since we have various kind of movement, we'll represent it right here with our static classes that return the move object. So first we have make move, which is like a normal movement, forward or backward by a number of steps. We take the pawn and step, and that is. And we have switch place, which is another kind of move object that take a pawn and another pawn on the board and switch their places if possible, of course. And splitting move is for the card 7, you will have a choice to split the move between 2 pawns of the same color. And this is where you make a move object for that kind of move. And also the send home here is for the sorry card, where you switch place with one pawn of the opponent team and send that pawn back home. So for the computer player, which like I said, inherit from the human player, it also have a method with the same function of getting a movement from the card which is drawn in the current turn. But it has a different name right now, which is player decision on movement, which is a really long name, but it's okay for now. It will decide the movement by itself, not like the human player, which will decide the movement based on the user input. But it's also written a movement object right here. Okay, so after we create the movement object, we will put it in the game configuration, which we have right here in the game. The game configuration consists of the position of the pawn, the placement of the pawn on the board, which you will find weird, but that is how we place the pawn we have on the board, and of course the board. So these are the methods we have right now for the game configuration. And of course we have right here is 2 methods that take in the move object and modify the board with that. So we have the validate, which return a Boolean. This is where we decide if a move is suitable for the current board or not. If it is not, this validation method will return false, and that move will not be updated into the board. But if it is, we will update the board with the same movement, and the change will take place. But those changes will only take place on the position. It's not yet implemented onto the board string we have right here. So we need this update placement method, which will decide where the pawn will go on the board. And from that, we are able to print the board onto the console. These are helper methods to help other human player and computer player to interact with the current board to make decision for themselves. So I think that is all we have for class diagram at the moment.
Thank you, Tom. I just wanted to mention a few things about some challenges that I know I had. I was working on the computer player portion of it, and it's kind of challenging to conceptually think about how I would make a move instinctively. You know, you don't usually think too hard on, oh, I got to move this player somewhere, but I had to implement a way for the computer to take what I think is the best move to make and the most logical move to make and implement that and make them make their decisions based off that logic. So that was a fun challenge. I overcame that with just perseverance, honestly. Honestly, I played a board game with my family. So I was able to kind of write down my thoughts every time I made a move, and that helped me process the computer players portion. Did anyone else have any challenges?
Okay, so since I implemented the game configuration, yes, I do have many challenges regarding it that I have overcome. So yeah, like from the position, how I implemented the position is not really easy to decide the placement on the board based on it. But it's since I have comes up with this idea, I kind of figure out on the way how to do it eventually. And also the movement, which is really based on the rule to validate them, because I have to read the rules many times since this is kind of the first time I have heard about the game. But it's really fun that we have like made that possible, I guess. So
And I just want to talk about like what Marissa was saying earlier about implementing the sorry method. So right now we're just working on implementing a switch function. Hopefully we'll get that working, and then two cards that use it, I believe, are 11 and sorry, or they're two different ones. But yeah, that's our main goal to implement. And I think that's all the time we have for. So thank you guys for watching. And yeah.
Thank you, guys.